Let's take a look at this word problem. Now, when you're thinking about word problems, you got to turn the words into math, right? But this is specifically about a quadratic, and you're given the equation, so you know it's about a quadratic. So think about these questions and the different parts of the graph: vertex, x-intercept, y-intercept, some other point. There aren't that many things to think about. So which one of these is the vertex? I think that one is probably the somewhat easiest. The y-intercept is the really easiest one, right? So vertex says maximum or minimum. That's the clue. So how about the other ones, B and D? Do you think that we're going to use the quadratic formula to solve those? That those are kind of representing an x-intercept? One of them is an x-intercept, and one of them is kind of a sort of an x-intercept like that. So identify the key feature, and that tells you what math you need to do. So let's do the y-intercept. You can just look at the equation, right? Write it as a point, as always. When you explain these anything throughout all semester, explain the input, explain the output. How do they go together? What do they mean? So t equals 0 is when Thea first threw the ball. 8 is the height of the ball above ground. Use the specific terminology that you're given in the word problem to answer these explain questions. Like that. I have an alarm going off. Let's see if I can turn it off real fast. There we go. All right, so there you go. The ball was first thrown. That's the 0 from 8 feet above ground. That's the 8. Awesome. How long does it take to strike the ground is going to be the x-intercept. Set the equation equal to 0. Always do that. Throw the values into the quadratic formula. Type it in the calculator. If you need some help, I can show you some tricks on the calculator. Let me know in class. You get 2 answers. Do you think you could write a sentence explaining that negative value in context? Share it in class next time. See if you can come, unless I already told you what the answer was. But anyways, the positive answer is the only one that's appropriate to answer this question. The ball strikes the ground. There you go. All right, the maximum height, this is the vertex. So to start off with the vertex, we need to calculate the h value. And then we take that number and we plug it into the equation to calculate the k value. And then, so 1 second after Thea threw the ball, maximum height, 24 feet above ground. Like that. Last question, above 12 feet. This is going to be an inequality. And what I suggested in Unit 1 for these more complicated inequalities is to just set it equal to 0 and solve it normally. And then at the end, think about what the greater than or other inequality might mean. So another quadratic form. And if you can visualize this, what we've really done is we've taken the original graph of Thea throwing the ball and it hitting the ground, and we have shifted it down 12 units. So now that when we calculate the x-intercepts, the time above the x-axis is the answer to this question. Like that. Throw the values in there. This is different than the other one, so the C value is -4. Type it in the calculator. We get 2 positive values. Now, in the past, I suggested that you do the number line and you test the intervals, but I think common sense tells us that the time above 12 feet is in between these 2 values and not 0 to this one or 1.866 to the 2.22 that we calculated earlier. So I'm going to subtract those 2. The ball is above 12 feet for 1.732 seconds, like that. Awesome.